about common logarithm. When we talk about common logarithm, we are talking about the common number we use in mathematics, the common base. And what is the commonest base we use in mathematics? That is base 10. That's base 10. And we know the rules of logarithm. When we talk about multiplication, division, power, roots, change of base. In that instance, we are talking about general, any number base. But because we have our four-figure table in base 10, and we also have a natural logarithm too. That is base E for natural logarithm. We'll talk about this one later in the future. But for now, we are talking about common logarithm. Why do we talk about common logarithm? Because most of the numbers you operate with in mathematics is in base 10. And we can easily manipulate under base 10. Now let me quickly go to some things here to know. You know, in logarithm, let's say we have 3,000. Let's start with this. 3,000. We can say this is equal to 3 times 10,000, 1,000, yeah. Which is equal to 3 times 10 raised to power 3. Please take note of this. That is why whenever we want to do common logarithm, we first of all treat standard index. That is indices in base 10. Standard indices in base 10. With this, you can see that 3,000 is equal to 3 times 10 raised to power 3. And in our four-figure table, we have from 1 to 9.999. Therefore, if I want to look at this one, if I want to express it, I can say log 3,000 to the base of 10 is equal to log 3 to the base of 10 plus log 10 raised to power 3 to the base of 10. Please follow as I'm doing this. Now, this one, we can still look at this as log 3 to the base of 10 plus 3 log 10 to the base of 10. And from our knowledge in logarithm, we know that when this one and this one are the same, this one is 1. So it's going to be 3 plus log 10, 3. You can see. So have this in mind. That is, because we are doing it in base of 10, we are going to have some natural numbers, as in for the powers of 10 outside. And this one we will check from the four-figure table. We are going to check this from the four-figure table. And because this one here is less than 10, this one here will always be in fraction, as in decimal. It will always be less than 1. This part that we will check from the four-figure table will always be less than 1. It will be 0 point something. 0 point something. Therefore, let's look at this. Log 10, 3 is equal to 0.4771. So, if I want to get the logarithm of 3,000 to the base of 10, it's going to be this 3, you see from here, 3 plus 0.4771, which is 3.4771. If you can perceive it, understand the logarithm that you are going to check from this standard base, standard index, you will just to get that one from your four-figure table. And that is why, so when we have it like this, we are going to call this one the character part, and this one is man-system. So, normally, when you are looking for the log of a number, you don't need to express it like this. I'm just telling you how it is gotten, how it gets up. You will still see later on when we are handling some other ones, why perceiving it from this will help in understanding. So here now, this is it, character. Now let's quickly look at some to increase our understanding. Now just to enhance our understanding, let's quickly do these ones. The question says express the following in standard form and then find their logarithm. The first one is 34.12. 34.12. Now if we have 34.12, I want to express in standard form. It's going to be 3.412 times 10. You remember now, this is 34. So that's 3 times 3.4 times 10. That is in standard form. So log 34.12 is 10 will be equal to log 3.412 base 10 times log 10 base 10. Just trying to simplify it. Now, we will get this one from the four-figure table. And we have to get to 34 under 1 difference 2. You will check the four-figure table, you will see 3, 4. And then you will check 1 and then add the difference under 2. Now, this one, checking this one from the four-figure table gives us 0.5331. And we know that log 10 base 10 is equal to 1 plus 1 plus 1. So this is going to give us 1.5331. So I've broken it down. With 10, just looking at this number, you don't need to break it down. You don't need to break it down. For somebody that is being confused, that's why I'm doing this, that is confused about logarithm. You know, this is just a quick lesson for our students preparing to get admission to the tertiary institution. Let's look at the second one. I have this one to be 192.7. Checking this one is going to be 1.927 times 10 raised to power 2. That is the standard form. Now, what do I do next? I will go to check. So this one will now be 190.7 is equal to log 1.927 base 10 plus log 10 raised to power 2. So this is going to give us log 10 1.927 plus 2 log. I know that this one is 1. So we are going to have 2 plus log 1.927 base 10. You check this one from the four-figure table. That is 19 under 2 difference 7. 19 and you check under 2, then add difference of 7. Difference you get from under 7 to it. So our answer is going to be 2 in 4. This one is 2 plus 0.927 that this character, the character is always gotten from the powers of 10. So there's so many people get confused about, oh, how do I get this number? It's very easy. Just look at it. This one is 30. This is 1. This is 100. This is 2. Get it like that. Now look at this now. The third one is 0.0034. And if you want to express it in standard form, it's going to be 3.4 times 10 raised to power what? 1, 2, 3. Or you can count 1, 2. This is the third number from the decimal. So that's going to be minus 3. This is standard form. You can see. And then if I want to get the logarithm, it's going to be log 10 and log 0.0034 base 10 is equal to log 3.4 base 10 plus log 10 base power minus 3 base 10. You can see. From here, I can now say this one will be equal to log 3.4 base 10 plus minus 3 into log 10, 10. Please take note, this is a peculiar situation. And that's part of the reason we are using base 10, studying common logarithm. When you have the powers of 10 like this, please don't tamper with it throughout the calculation. Don't tamper with it. So when we are doing something like this, we don't always put it like minus 3. We make it bar 3. Bar 3, that is, we put the minus sign up here. You know, log 10 base 10 is 1. So it's going to be 3.4 plus bar 3. Please take notes. I have told you, take notes. We place it like this, bar 3. And then, this is the one you will check from the 4-figure table. You will check logarithm of 3.4 from the 4-figure table. This one is 0.5315. So at the end of the day, log 0.0034 to the base of 10 is equal to bar 3.5315. Note, the character is negative. The mantissa is positive. That is why we place it as bar 3. And if we put minus in the front, it means everything here will be minus. And that will negate the rule of mathematics. Which means that it should be minus 3 plus 5315. Which is going to be like minus 2.4685. Minus 2. Yes, that's the real answer. But for the purpose of our manipulation using 4-figure table, this is the best way to leave it. You will know the reason later on. Okay, I think I still have another one. The last one is 0.000002. So a standard form, this is going to give us 2.7 times 10 raised to the power minus, let's see, 1, 2, 3, 4, 5, 6, minus 6. So if I want to get the log, it's going to be log 2.7 base 10 plus minus 6 log 10, 10. So by the time you look at this, this is going to be bar 6 plus log 10, 2.7. So this is the part I will get from the 4-figure table. I get this one from the analysis of the standard form of this number. So what is log 10 2.7. Log 2.7 base 10, sorry. So that is 4314. And it's going to be 6.4314. You see, when you have it like this, you have it like this, you have it like this. You can easily work it back using the anti-log table. You can easily work it back using the anti-log table. But if not, we try to work this one. At the end of the day, we left it in minus. It will still be a bit difficult. We will still have to convert it back to this form to use that anti-log table. Else, we are going to have two anti-log tables. But with this format now, we can work with one anti-log table. Please take note of that. Know this, know how to express it when it has negative power, and then from there, you can work out so many things. Let's do some reminding. Let's say we have numbers m and n. If I want to multiply these two numbers, what will I do? I first of all find log of n to multiply n by n. What do? I will find log of n to the base of 10 from the table. Log of n to the base of 10 from the table. I will add the two logs. So what do? Let me do it like this. Number log. From the rules of logarithm, we know that when we multiply two numbers, we are going to add the logs. So we are going to find log of n, log n, log of n, and then to multiply this one now, we are going to add this. You've gotten that? We are going to add. Once we add, our answer is here. This answer, we are going to find antilog. We are going to find antilog. That's how we get it. Simple. So also, if we are going to divide n by n, we get n, we find the log of n, we find the log of n. At the end of the day, the answer here will be the log of this operation. The log of this operation here. If it is, for multiplication we have added. For division, we are going to have subtraction. After we have subtracted, this will be the log of the answer. The log of this operation here, that is division. So the answer here, we still have to get it because it will be in logarithm. It will be in logarithm. So we will now go and check the antilog table to get the original answer. So the antilog of this log is the answer, is the final answer. This one is just a preliminary answer. Preliminary. Now, we have gotten this. Let's look at when we are going to find power. Let's say we have n raised to power k. How do we do that? We just go straight. Number log. We find n, the log of n. Because we are raising it to power k, what do? We multiply by k. You remember, for logarithm, when you are doing this, you multiply by this one. That is log m raised to power k. any base. So this thing is now being applied to base 10. So this will now be k into log m. After we have gotten this, we get our answer. Once we have gotten this, we will find the antilog. Antilog will give us the actual answer. So this antilog of this will now give us the real answer we are looking for. Since I want to work something like this, n to the root of k. You know, it is also the same thing as n raised to the power 1 over k. Then, how do I go about this? I will have number log. So to find this, I first of all find log n from the table. Once I have done that, I will divide this log by k, or multiply by 1 over k. So it will be log n divided by k, or 1 over k times log n. It's still the same thing. So the answer I get here now, if the final answer is to get this, the answer I get here, I will just find the antilog. From the tables, and this antilog will now be. So this is your final answer. The answer here is the preliminary answer. So this is the final. So you can see, it is just like playing game, and that is all. So you have known how to do the multiplication, division, power, roots. Because you have known how to do this, sometimes you don't even need to start finding the antilog along the way. You might just need to go straight and perform your operation continuously until you get to the final answer. Now before we go on, let's talk about a point of interest. And that is where we are finding the roots of numbers less than 10. That is, we are finding square roots, cube roots, root to the fifth root, etc. You know, we said something like, if we have a number like 3.2 times 10 raised to the power minus 3, and you want to express the logarithm of this, we will make it like this, bar 3 point the logarithm of 3.2. So I just want you to understand this. So if we have it like this, and we want to find the square root, it will be very problematic. You know why? This one here, by the time we divide by 2, is going to remain minus 1. And you cannot join that minus 1 to the positive number at the back. To the positive number at the back. So let me quickly find the log of 3.2. 5051. So this one is going to be bar 3 5051. You can see log 3.2 times 10 minus 3 is going to give us that. So if I want to divide this one by 2, let's see. I'm going to have bar 3.5051. So dividing by 2 is going to give me bar 1 to this place. It won't jive because this one is positive. Bar 1 is negative. So it's going to give me problem at this end. So what do we do? To make it easy, it's just little manipulation in mathematics. It's not only in common logarithm you use it. You use it in so many other aspects too. Just to make your work easy. So what do we do here? You know that bar 3 is equal to bar 4 plus 1. equal to bar 5 plus 2. Depending. You can also say something like bar 5 is equal to 8 by 8 plus 3. But please, when we want to do this kind of manipulation, most of the time, this number here will be of the negative value, of higher negative value. Then we add positive value to make it equal to the negative value we started with. Try to get what I'm saying. Bar 4 is of higher negative value than bar 3. Bar 5 is of higher negative value than bar 3. Bar 8 is of higher negative value than bar 5. If what you want to divide with is still the same thing as this one, leave it. I will now do this. So to find the square root, of 3.2 times 10 to the power minus 3. I want to find the square root. It's going to be half times 2. If I want to find this one, I will need to find the log of this and divide the log of it by 2 and then find the antilog. So let me quickly work this out. It's going to be you can see that 3.2 times 10 to the power minus 3. Just for our ease, the log is going to be bar 3.5051. You can see. And I want to find the square root. It is going to be 3.2 times 10 to the power minus 3. It's going to be bar 3.5051 divided by 2. And from my explanation before, you know we cannot do this one straight. What do we do? I will now make it like this. Bar 4 plus 1.5051 divided by 2. Remember what I said the other time, that bar 3 will be equal to bar 4 plus 1. So you can see, it's going to be bar 4 plus 1 plus 5051. This one and this 5051, they are in the same state. So you can add them. Now this one will now be equal to bar 2 plus 2 in 1, 0 in 15, 0.752, let's say 26. That is the log of this number. So, bar 2.7526. So to find this one now, we will now find the antilog of this. We will now find the antilog of this. This will now be 5 times 10 raised to the power minus 2. That's the answer for this now. 5.657 times 10 raised to the power minus 2. Or you can say 0.05657. This is, you can see, the main thing I want to let you see is how we manipulate this. We will make the first number to be divisible by this number below. Are you getting it? Assuming we want to find the sixth root, we are going to add 3. We make this one bar 6 plus 3.5051. Get what I'm saying? Assuming I want to get 6 of 3.2 times 10 to the power minus 3. So when I'm working the logarithm, it's going to be bar 6 plus 3.5051. Now look at this. Assuming I want to make it 6 roots of this. This one is going to be bar 3.5051 6 plus 3 is going to give me bar 3. 6.5051 divided by 6. You've gotten that now. That's what I just want you to see. Now, assuming I want to find cube roots of this. Cube roots of this. That is, this place will be 3. This place will be 3. You understand? This one is now going to be bar 3 plus 0.5051 divided by 3. You know what? 3 can go conveniently in this number. 3 can go conveniently in this number. So if this is 3, bar 3, bar 6, bar 9, you can leave it. You don't need any other manipulation. So, like this one now, it's going to be bar 1.51 in 26, in 25, 8, in 11, 3, let's say 4, everything 4. So, if I'm going to find the cube roots of 3.2 times 10 to the power minus 3, this is going to be the final logarithm. And after working this out, I just find the antilog. So you can practice this so that it will be second nature. And once you get it in your test or examination or anything, you get it easily. So, since you have gotten to this, I don't see anything difficult in logarithm. But if you have any question, please direct it through your comments or the channels in the description. Let's quickly do one or two examples and we'll close from there.